Alright, so this is the video tutorial key for the Unit 5 take-home test. We're going to get working on page 1. Okay, I've already color-coded number 1 for you. It says the skeleton equation above, which just means it's not balanced yet, represents a chemical reaction. Okay, and it asks you to list the reactants. So the reactants go into the reaction, the arrow's the reaction. So reactants go into the reaction to produce the products. So go ahead and rewrite those down here. So you're going to say calcium and HCl. Okay, you're going to do the same thing for the products. Now, which type of reaction is this? You're identifying reaction types. Remember, you have synthesis, decomposition, combustion, single replacement, or double replacement. Those are the 5 that we've been working with. So 1 capital letter, calcium, that's a pure single element. That's 2 capital letters, that's 2 elements, that's a compound. So a single and a compound means it is a single replacement reaction. Reactants in the following reaction, it's the exact same you're going to do number 1. Okay, where the reactants are before, so in this case it was Ca and HCl. That's what you're going to do to solve number 2. Number 3 says in a chemical equation, the large number written in front, which would be like this number right here. That number written in front is called the coefficients, A. Okay. Now, coefficients are the only things that you're allowed to change. So when balancing a chemical reaction, you use coefficients. Law of conservation of mass says that matter cannot be created or destroyed. Okay. So that says that whatever you have before a reaction, if I have 2 sodium before, I have to have 2 sodium after. Because matter cannot be created, I can't have more, and it can't be destroyed, I can't have less. So because of the law of conservation of mass, we have to have a balanced chemical equation. Number 5 I've already answered in this video. In a chemical equation, I'm thinking number 6. In a chemical equation, the small number written after the elements, which would be like this one right here. Okay, the small number is called the, you should know the vocab for that. Number 6 is the one I was thinking, we've already answered this. When balancing the chemical equation, the blanks are the only things you're allowed to change. Okay, we already talked about that, so rewind if you need or look up at the previous question. Alright. Number 7 shows you 4 different reactions, A, B, C, D, and only one of them is balanced. So it asks you which of these is the correctly balanced chemical equation. So I'm going to give you time to kind of sit and look at that. Okay? And you're going to count up what you have. I've got 2 magnesiums, 2 chlorines, and after I have 1 magnesium and 2 chlorines. So my magnesium aren't balanced in A. That can't be the right answer. Okay. For B, we've got 2 magnesium, 2 chlorine, 2 magnesium, 4 chlorine. Be careful with that. Remember, the coefficient out front distributes to everything. So 4 chlorine, 2 chlorine, that can't be it. Right. Keep going. I want you to look at C and D and try and figure out which one is correct there on your own. So I'm just going to highlight that you're supposed to answer this one on your own. Okay. Same thing here. I want you to answer that one and that one on your own. Okay. Number 8 is asking you which additional product balances the reaction below. So I've got iron sulfide plus hydrobromic acid equals blank plus iron bromide. Okay, probably iron 2 bromide. So they're asking you to fill in the blank there. Now, it's also asking you to balance. So it's not just saying what is it, but which one's correctly balanced. So I have 2 capital letters here, 2 capital letters here, which means I've got 2 compounds. So when I have 2 compounds on the reactant side, it's a double replacement reaction, which means my anions are going to switch spots. So S and Br are going to flip-flop. So instead of FS, we have, FES, we have FEBr, which is right here. Instead of HBr, I have HS. So whatever this is, it's going to have an H and an S in it. So H and S, S and H, Fe, no. H and Br, no. So we're looking at these ones. Okay. So if we've got an H and an S, you'll notice that hydrogen's in family 1. We don't often work with hydrogen. We will when we get to acids. But hydrogen's in family 1A, so it's going to make a +1 charge. Sulfur is in family 6A. Let me get that on camera, sorry. Sulfur's in family 6A, so it needs 2 more electrons to be like family 8A. Sulfur's going to make a -2. and crisscross that. 1 and 2. So I didn't crisscross. You see what I did there? Whoopsie. The 2 comes over this way, and the 1 comes down this way. So it's H2S, invisible 1 like this. Now this is the same thing you're going to do on number 9. It says, given the balanced equation, I2 plus 2 potassium bromides yields blank, X. Okay, blank plus Br2. So you have to figure out what goes here in the blank. This is a single replacement reaction. So do it the same way we did number 8. Go ahead and pause here. Number 10, the combustion reaction of propane, C3H8. That's what propane is. What are the products? Now, you should have this one memorized. For my class, you wrote this as a key concept that should be memorized. Combustion reactions always have the same 2 products. Check your notes if you don't know this one. But you should know the products of combustion reactions. Okay? That's something to have memorized. Please turn to page 2 with us. Okay. Number 11, 12, 13 is asking you to balance and write the types of reactions. So let's start by doing types of reactions for all 3. I've got 1 capital letter, which means a pure element, plus 1, 2, 3 capital letters, which means a compound. So a single pure element plus a compound is a single replacement reaction, and that should be fine if you want to use our abbreviations. Down here, I've got 1, 2, 3 capital letters, so that's a compound. 1, 2 capital letters, so that's a compound. So when I have double compounds as my reactants, it is a double replacement reaction. Down here, I've got a single and a double, so sometimes people say single replacement, but remember this is CHO. CHO reactions are always combustion reactions, and here's the answer to number 10. Products are always carbon dioxide and water, right? There you go. Okay, coming back and balancing. For home students, you have to show work on these, okay, just to make sure we're getting these correct. So let's do this first one as a group. Okay, write down what you have, magnesium, cesium, and then SO4, sulfate, stays the same on both sides. So I can go ahead and just keep it together, SO4. Now I'm going to copy it down in that same order over here, SO4. Okay, I apologize, my handwriting, I'm at a really weird angle here. 1 magnesium to start with, 2 cesium, and there's nothing written here, which means invisible 1. So 1, 2, and 1 to start with. 1 magnesium, 1 cesium, nothing written there, so 1 sulfate to start with. So we're already balanced except for 1 and 1 is balanced, 2 and 1. Now remember, all you can change is the coefficients out front to balance, which means you can only multiply. So I have to make my smaller number into my bigger number by multiplying by 2. Okay, I'm going to take the number I multiply by and make it my coefficient. So that's 1 times 2, 2 cesium. And putting a 2 there doesn't change anything else. So now I've got 1 and 1, 2 and 2, 1 and 1. We're done. When you're done balancing anything that's blank, you can go back. So this is a 1 to 1 to 1 to 2 ratio, like that. Alright, you're going to do the same thing for 12 and 13. You should probably pause for about 3 minutes and get some of those done. Number 14, determine the ratio of coefficients needed to balance this reaction. They're asking you to balance just like you did here. They're just asking you to do it in multiple choice form. Okay. So F2, NaI, NaF, I2. It's a single replacement reaction. Fluorine is replacing iodine, and that's why it's NaF, and then iodine is our new single. Now, guys, pay attention to the fact that it's F2 and I2. Those are Brinkelhoff, remember? B-R-I-N-C-L, Brinkel, H-O-F. Those ones are always 2's when they're pure. Okay. So if you want to rewrite this over here so that you have room to balance and show your work, that's fine. I'm going to just so it's a little more clear. Blank NaF plus I2. Okay. Fluorine, sodium, iodine, fluorine, sodium, iodine. I have 2 fluorine to start with, 1 and 1. I have 1, 1, and 2 to start with. So in order to balance my fluorines, I take the smaller number and I multiply in order to turn it into the bigger number. So times 2 equals 2. In order to do that, I write it here. So now it's 1 fluorine times 2 equals 2. But that doesn't just change fluorine, it changes sodium as well. So now I have 2 sodium. So now to balance sodiums, I have more on this side, so I have to change the smaller number times 2. Okay. That doesn't just change sodium, that changes iodine times 2. So now I've got 2 and 2, 2 and 2, 2 and 2, so that works out. Blank, 2, 2, blank, I'm going to make that 1, 2, 2, 1. So my answer is 1 to 2 to 2 to 1. D. Okay. What kind of reaction is being shown here? We already answered that if you were listening in the video. Otherwise, take a look at it. You should be able to answer that one on your own. Okay. Number 16, oh my goodness, Roman numerals. That bugged you in Unit 4. There's a good chance you have forgotten it even if you knew it. So remember, when it comes, we've got zinc nitride, zinc 2 nitrate, zinc 2 nitrite, zinc nitride, or zinc nitrate. The question is, does it need a Roman numeral or not? Okay. I'm going to have you take a look at your periodic table. Remember, there's our dividing line, nonmetals, metals. Now, all metals need Roman numerals except for the ones that always make the same charges. So family 1 metals always make a +1 charge, so they do not get a Roman numeral. Family 2 metals always make a +2, so they don't get Roman numerals. Then we have the 1 and 1b that always makes a +1, the 2 and 2b that always make a +2, and the 3 and 3 that always make a +3. Let's see if I can do this. Those ones don't need Roman numerals either, but everything else does. So where does zinc fall in this lot, huh? Should we find it? Right there. One of the 2 and 2b that always makes a +2, which means zinc does not get a Roman numeral. So automatically, you should cross out A and B. Don't pick them. Then your choices are zinc nitride or zinc nitrate. Okay. So I'm going to let you guys finish answering those on your own. But they're telling you that zinc, Cn, is chemically reacting with, which means plus, nitrogen, N. Okay, like that. So go ahead and write the formula and see what you come up with here. Make sure it's named properly. Number 17. We had a warm-up like this in my class last week or 2 weeks ago in lab. You place a piece of gold, which we didn't do because that's too expensive, but you place a piece of gold in potassium chloride solution. So that's what I did. Gold is Au plus potassium chloride, KCl. After 2 hours, what do you expect to see? Well, this is a single replacement reaction. We did single replacement with things like magnesium and iron and copper. But gold is a metal, so it is trying to replace potassium, the metal. So in 2 hours, what would we expect to see? Single replacement reactions are real special, guys. Anytime you see single replacement, you should remember to look for activity series. Anytime you see polyatomic, you look here. Anytime you see activity or single replacement, look here. So we need to ask ourselves, is gold strong enough to replace potassium? Gold is way down here at the bottom, which means it's not very active. Potassium is way up here. So remember I taught that these are the movie stars. Lithium can steal your girlfriend. Is a movie star. Okay? These are our science nerds. Gold cannot steal your girlfriend. So if gold comes over and says, hey, chlorine, do you want to go on a date? Chlorine's going to say, no, I'm dating a movie star. I'm good. Okay? So gold is not reactive enough to replace potassium. So in 2 hours, you're going to have no reaction. Okay? The gold metal will be replaced by no. Bubbles will be no, because bubbles mean that there's a chemical change, and there wasn't. There would be no reaction visible because gold cannot replace potassium. Ding, ding, ding. Gold will combine with potassium, forming no reaction. Okay, there is our key right there. No reaction visible. Okay. Sodium chloride reacts with copper 2 sulfate. This is a double replacement reaction. So remember, for double replacements are anions, which means chloride and sulfates are going to switch spots. So go ahead and answer those ones. Why don't you pause for a minute to do that? When sodium oxide decomposes, okay, when this breaks apart, I've got sodium and oxygen. When it decomposes, what's it going to break up into? That's what they're asking you to do here. Now, sodium and oxide. There's no such thing as oxide by itself. Remember, when oxide breaks up, it's oxygen. So be careful that there's no such thing as oxide by itself. We haven't used dioxide before. Hydroxide if I can find it here. Let me see. Hydroxide's right there, OH. That's different than oxide. Okay. Page 3. Alright, now this I'm going to give you more time to work on your own. But there's two things you need to do here, and you do need to do both. It says predict the products, which means fill in the second half of the equations, and then balance the reactions. Okay, so 1, 2, 3, 4, 5 problems. You do need to balance all 5 of them. We did try to give you enough room for that. Okay. This is a double replacement reaction. I know because there are 1, 2, 3 capital letters, so that's a compound, plus 1, 2 capital letters. That's a compound, because there's more than 2 elements, or more than one element. So I'm just going to make a note to myself that that's double replacement. I recommend you do that as well. Okay. In double replacement reactions, the anions switch spots. So instead of silver nitrates and potassium sulfide, you're going to get silver sulfide. It's going to be Ag bonding with S, and then K bonding with NO3. And leave room to balance. Okay. That is not done. That is not the answer there. Okay. We always have to write the formula. We just made a new compound, silver sulfide. That's a new thing. So I have to write the formula for it, which means charges, crisscross, reduce, and erase. Symbols are right there. Silver is the one element in group 1B that always makes a +1. You should have that memorized from Unit 4. Sulfur, over here in family 6A, is trying to be like family 8A, which means it needs 2 more negative electrons, so -2. So when I crisscross that, okay, the 2 is going to come here, Ag2S1. So the formula for silver sulfide is Ag2S. Potassium nitrates, because NO3 is nitrates. Potassium's over here in family 1, so it makes a +1. Nitrates, you'd have to look at your polyatomic list, makes a -1. So when we crisscross, they're both 1s, which means they're invisible. So KNO3 is the correct formula for potassium nitrate. And then, my friends, we balance. You have to show your work. Home class, NO3, K and S, silver, nitrate, potassium, sulfur. I'm going to copy that in the same order. Silver, nitrate, potassium, sulfur. 1, 1, 2, and 1. Invisible 1, invisible 1, 2, invisible 1, subscripts. Silver is a 2 on this side. Nitrate is an invisible 1 on this side. Potassium is a 1. Sulfur is a 1. Okay. Why don't you pause and try balancing that? Okay. So remember, when we balance, the only thing we're allowed to change is the coefficients out front. So I'm multiplying to make the small number turn into the bigger number. So 1 times 2 equals 2. We're going to put that 2 there. Now, that 2 distributes to everything. So that's 2 silvers, like we were trying to do. But the unintended consequence is that we have 2 nitrates now. So my silver's balanced, but I unbalanced my nitrates, and that's okay, that'll happen. So now I have more on this side, so I change the small number over here into the bigger number by multiplying by 2. So that changes NO3, but it also changes potassium, my unintended consequence. Okay. So now I have 2 potassium, but I wanted 2 potassium. 1 sulfur, 1 sulfur. So that's 2, 2, 2, 2, 2, 2, 1, 1. So 2 blank blank 2. When I'm done balancing, the blanks turn into 1s. If you'd like to rewrite that more clearly, it's 2 to 1 to 1 to 2. 2, 1, 1, 2. Alright. We've got a combustion reaction here, CHO. So you're going to balance that. Predicting products for combustion should be really easy. We already did this on the other side. The products are always carbon dioxide and water. Okay. This is another double replacement reaction. So your anions are going to switch spots. Let's say single replacement reaction, LiCl. I'd like to do this one with us. Okay. So I have LiCl, lithium chloride. That's a compound, 2 capital letters, 1 capital letter. That is a single pure element, so single replacement. Now, not all single replacement reactions are possible, so we're going to have to be careful on this one. Fluorine is a nonmetal, which means it's going to try to replace the nonmetal, which is chlorine in this case. So I'm going to reference my activity series. Fluorine is trying to take the spot of chlorine. Chlorine is more active, so the movie star can take the nerd's girlfriend. Okay, so it's going to be Li bonding with S, and then we're going to end up with chlorine got broken up with and is all single. Now that we got that written down, we have to go back and check it. Lithium is in family 1, it makes a +1 charge. Fluorine is a halogen, so it's in family 7, it needs one more electron, -1. When we crisscross, it's Li1F1, so that's fine. But chlorine, guys, be really careful. There's a Brinkelhoff one. Pure chlorine, Brinkelhoff, is one of the 7 that's never really alone when it's pure. Okay, so like pure magnesium down here, that can just be Mg. That's fine. But Brinkel, like Hoff, H-O-F, and H-O right there, and H-O right there, and Cl, Brinkel, those are always twins when they're pure. Okay. If you didn't remember that that was Cl2, then you're not going to balance it correctly. Okay, so be really careful with your Brinkelhoffs. If you don't predict the right product, Cl2, you're going to balance it wrong. Li, Cl, F, Li, Cl, F. We write down how many we have of each. Invisible 1, 2. Visible 1, 2 chlorines, because we didn't forget Brinkelhoffs, and then 1 fluorine on this side. Okay. I'm going to let you pause and try balancing this one on your own. I'm not going to give you the answer to that one. Okay, so we'll just go like this. Fill those ones in on your own. Looking at number 24, I've got 1 capital letter plus 1 capital letter. That means 2 single compounds, which all they can do is combine, which is synthesizing. Combining is synthesizing. Okay. So magnesium plus oxygen makes magnesium oxide. That's the name. And we're going to write them together, MgO. Now we need to come back and check our charges. Magnesium is in family 2, which means it has 2 valence electrons, and it's going to lose them both. Let's make a +2 charge. Oxygen's in family 6, which means it has, 6A, which means it has 6 valence electrons. It needs 2 more to be like 8, so it makes a -2. When we crisscross those, they're both 2's down here. I'm going to write it really faintly, because if they're the same numbers, then they cancel out. And so it's MgO is our final formula. So we cut that in half and balance it. Okay, please take some time and finish balancing this before moving on. Number 25, what could replace hydrogen? Okay, people get stuck on this one, activity series. They look for hydrogen down here with the nonmetals, and it's not on that list. Hydrogen is right here. Okay, it's in parentheses. We're going to use hydrogen activity series when we do acid reactions in Unit 12. But what can replace hydrogen? Anything above it. Okay, the movie stars are going to take hydrogen's girlfriend. Nothing below it can replace it. So that's what you're looking for on number 25. You need to use your activity series. Let you do that one on your own. Okay, if methane, which is CH4, if methane reacts with oxygen, what will the 2 products be? I'm not going to give you this answer, but I am going to go this, and this. Okay? We've said this several times today. You should be able to figure out what type of reaction that is, and then what the products always are. What could replace iron in the following reaction? This is the same thing as 25 with a different element. Okay? They're saying if you have iron 3 oxide, Fe2O3, plus blank, what could possibly replace that? So you need to come here and find iron. Okay? Iron replaces everything below it, and it is replaced by anything above it. So lithium can steal iron's girlfriend. It can replace it. Gold cannot take iron's girlfriend. So use this activity series and go ahead and answer questions 27 on your own. Number 28 also uses the activity series, and be careful, it says increasing activity. That means low to high, increasing. Low to high, like if you increase the volume. And it says increasing activity right here, low to high, so follow it. If you do it backwards, that choice is there as well, so just be really careful here and on your exam. Okay, take time, get caught up. Number 27 is all about Brinkelhoff, diatomic nonmetals. There are 7 Brinkelhoff elements. Okay, it's BrIN. Cl, Brinkle. Okay, that's bromine, iodine, nitrogen, chlorine. Now I'm a little bit mean about this in my grading. If you just put Br, that's wrong, right? Because that's the point of diatomic. Okay, if you're going to write bromine, that's okay if you're going to spell it out. But if you're going to use the symbols, you have to say Br too. So Brinkle and then Hof, H-O-F. You have to have those memorized. Okay. If you were balancing an equation and you said 2 oxygens like this, you'd be wrong. You would have to say 2 oxygens like that if it was by itself. Okay. So make sure you memorize this if you want to write yourself a note to memorize your Brinkle-Hofs. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. And that's only pure elements. Number 30. Number 30 is showing you calcium cyanide reacting with rubidium sulfite. Yes, sulfite. And it's asking you what's produced. That's a double replacement reaction. Okay, 3 capital letters plus 3 capital letters. Our anions are going to try and switch spots. So instead of calcium with Cn, it's going to be calcium with SO3. So I'm just going to help you with the first one. I'm not going to help you with the second one. But calcium is going to bond with SO3. Calcium is in family 2. It makes a +2. SO3 is sulfite. And it tells you right here, without that glare, sorry, that sulfite makes a -2 charge. So you're going to crisscross that and end up with 2 and 2. Now because those subscripts are the same, we leave them off. So it's just going to be CaSO3. So not CaCN, not CaSO3-2, CaSO3, not CaCN. Okay, so be careful with them. Predicts the products. It's a single replacement reaction, so you're going to need an activity series whenever you see single replacement. Okay, go ahead and try solving this one on your own. Number 32 says to predict the products of the reactions in a word equation. If they spell out the word magnesium and oxygen, you need to spell out the answer. And then they say balance the reactions in formula equations. So you're going to do all 3 of those. Predict the products, write the formulas, and then balance the formulas. So let's just look at this first one together. I'm going to let you do 33 on your own. Magnesium plus oxygen. I always say what kind of reaction it is because that changes how you predict the products. One pure element plus another pure element, that's 2 singles. All they can do is synthesize and make a compound. Magnesium plus oxygen is magnesium oxide. Okay, you name the metal, you name the nonmetal, and change it to ide. Now this is not magnesium 2 oxide. It doesn't get a Roman numeral because magnesium is in family 2. Those always make the same charge. So no Roman numeral, just magnesium oxide. Balanced formula equation means you need to leave room to balance, so blank magnesium. The formula for magnesium is just a symbol for magnesium, Mg. Now magnesium is not a Brinkle-Hof, so when magnesium is all by itself like that, it's just Mg with no subscripts. Plus blank oxygen. Now that's pure oxygen all by itself, so I have to check if it's a Brinkle-Hof, and it is. So pure oxygen all by itself is not O, it's O2. O does not exist in nature, O2 does. And then we're going to come over and put blank magnesium oxide. I'm going to show my work over here. 4 steps for writing formulas of compounds. First step is to do the symbols, Mg and O. Then we're going to do the charges. Magnesium in family 2, oxygen in family 6. They both make 2s. So when you crisscross, since they're both 2s, we leave them off. And the formula is just MgO. Now, if you forgot that oxygen was diatomic, you would have thought this was already balanced, and you'd have made that mistake. So we need to come back and balance it. Magnesium and oxygen. I've got 1 and 2, and 1 and 1. So my magnesiums are balanced, my oxygens are not. So I take the littler number and I multiply by coefficients to make it a bigger number. So I need to use the coefficient 2. So go 1 oxygen times 2 equals 2. But that doesn't just change oxygen, it changes magnesium. Okay. So now you need to balance magnesium over here. And I'm going to let you finish balancing this one on your own. You're going to do the same thing for number 33. Number 33, as you did up here, but this is a different kind of reaction. Sodium iodide plus fluorine. That is a single replacement reaction. 2 words plus 1 word. It's a compound plus a pure element. Be careful with Brinkelhoffs on this one as well. Okay, make sure you're looking up here. Write the word equation, then the formulas, and balance. Go ahead and pause here to get some time to finish that. Number 34, 35, and 36, all 3 of these numbers are using this equation. 2 aluminums plus 3 chlorines, and there's a Brinkelhoff, that's why it's Cl2, yields 2 aluminum chlorides. Okay, so it's asking you what's the ratio of coefficients. It's just 2, 3, 2. It's already done for you, so you just have to copy that down. It asks you what are the reactants, so go back and look at page 1 if you've forgotten that one, and it asks you what kind of a reaction it is. Okay. You should know the types of reactions, number 36, pretty well. Those would be what we would call easy questions as chemistry teachers. We hope everyone knows this. 37, predict the products. There's no plus sign here. No plus sign means all it can do is break apart and become sodium and oxygen. Okay. All of these say sodium and oxygen, though. Okay. Pure sodium, Na, plus pure oxygen, O. The only time we would use subscripts for pure elements is if they're one of the Brinkelhoffs. Now, Na is not up here, but O is. Which means pure sodium is just Na. Pure oxygen is O2. Alright, let's go ahead and take a look. Sodium acetate crystallizes in a liquid salt hand warmer when activated. I've got one of those. We're going to use them. They're pretty cool. The packet becomes warmer than initial conditions, and a precipitate forms. What kind of change is happening? Physical change, chemical change, extensive property, or no reaction. Okay. So the key words here, y'all, are that it's getting warmer, so it's changing temperature, and it's forming a precipitate. So it's asking you, is that evidence of a chemical change, physical change, extensive property, or no reaction? If you don't know this vocab, right here, look at page 1 in your fill-in-the-blank notes, because you need to know that vocab. We're getting close. Number 39. Which of the following is not evidence of a chemical reaction? Again, I'm going to write page 1 of your FIBN, your fill-in-the-blank notes. If you don't know those ones, you need to know all of that vocab. Go ahead and check your notes. Hey, 40, 41, 42. Our last 3 balancing. Okay. We've got one pure element plus another pure element equals a compound. So it's 2 things combining to make one thing. That's a synthesis reaction. So what type of reaction is it? There you go, synthesis. It wants you to balance it and then write your ratio right here. So like 2 to 2 to 2 or 4 to 4 to 4, whatever you end up putting here. Okay. I'm going to let you do those ones on your own. Okay, so please go ahead and get started on those ones. Okay. Go ahead and pause and work on some of those. Now I want to look at, wow, 43 and 36. That's definitely 43 and 44. That happens sometimes. 43 and 44. It's asking you, does this diagram properly show the law of conservation of mass? You need to say yes or no and how you know. Okay, we had one just like this on your quiz. Okay, so I'd like you to talk about this as a group, check it out, okay, but you need to say how you know. So ultimately what you're going to need to do is you're going to need to count how many you have before and after and compare. Because remember, dark circles cannot be created or destroyed, and light circles cannot be created or destroyed. That's the law of conservation of mass from page 1. Number 44, oh my goodness, my students have forgotten this. We did this day 2, which is the 9th and the 10th of November, so it's been a while, I understand. Okay, it's asking you the mass. Again, this is law of conservation of mass. Whatever it weighs before the reaction is what it has to weigh after the reaction. So if this is an arrow sign, which it should be, okay, this flask plus this flask reacts to make this flask. We can change it to be an equal sign. So just write it here. Blank. Treat it like algebra. Algebra blanks become x. So x plus 56 equals 82.3. Okay. How do you get x by itself? Well, you need to undo plus 56, which means minus 56.0. And if you did it to this side of the equation, you do it to this side of the equation. Minus 56.0 equals, put your answer right there. That's the mass of the first flask. I'll let you calculate that one out all on your own now that you saw how you're supposed to do it. Now, it's the same thing you're trying to look at here. It says in the following synthesis reaction, carbon plus oxygen, what's the mass of carbon monoxide? What's the mass of the final product here? Okay. So they showed you a diagram of it, and they gave you the numbers up here. So write yourself an algebra equation, y'all. 24, which is here, plus. So I'm just going to write the plus sign up there. And instead of the arrow, the law of conservation of mass says before and after have to be equal. And instead of question mark, my algebra brain likes x. 24 plus 32 equals x. So combine like terms to solve for x. I should be able to solve that one. Alright, naming and formula writing. These are Unit 4 problems. Yes, they are on your Unit 5 test. Yes, they will be on your fall final. Yes, they will be on your Unit 6 test. Unit 4, as promised, will not go away. So when you're naming the following, you name the metal, the cation, you name the nonmetal, and you change it to "ide." But you have to be careful for Roman numerals. Okay? Does gold need a Roman numeral? I can at least tell you that much. Okay, since they all end in IDE. Okay, really the Roman numeral is our issue here. Okay, gold is right there. So there's only 1 and 1B that always makes a +1, and that's silver. So these ones are my exceptions that I'm covering up. Gold is not an exception, which means gold has to have a Roman numeral because it can change charges. So A is wrong because it doesn't give gold a Roman numeral. To find the Roman numeral, we have to uncrisscross our charges. Remember, our charges, plus and minus, crisscross down to subscripts. Our subscripts uncrisscross back up into charges. So is it gold +1, gold +2, or gold +3 here? That's what we're really asking. So we're going to take this 3 and bring it here. We're going to take this invisible 1 and bring it up there. It's always then a negative, then a nonmetal, and positive cation metals first. Okay, try to name it from that. Formula for gallium nitrite. The only thing I'm going to caution you on is gallium nitrite. That's not gallium nitride. That's not gallium nitrate. So you're going to need to look nitrite up on your polyatomic list. Okay, we're way off on our numbering here. Number is nothing. Okay, apparently. This number, let's call it 38. And we'll call this one 38A, part 2. I don't know, whatever you want to number that as. Molar mass. This is not Avogadro's number, 6.02 times 10 to the 23rd. Molar mass is the same as atomic mass, and it asks you of the compound lead. Okay, that's a typo. What's the molar mass of lead? That's what it should say. The symbol for lead is Pb. So if we find it on the periodic table, the atomic mass, which is the bottom number, okay, so for lead right here, is the same thing as the molar mass. So in this case, the molar mass for lead is right there. I'm not going to circle it on the paper so I know if you're listening to me on mute or not. Number 38A, or part 2, whatever this one is. What's the molar mass of the compound LiOH? Okay, so now I have 3 different elements. I have lithium, oxygen, and hydrogen. And it looks like I have 1 of each because there's no subscripts. So I need to take 1 lithium, the mass here, plus 1 oxygen, the mass right there, plus 1 hydrogen, the mass right there, and add them all together. Now it does ask you to show work for credit there, so I'm going to highlight that if you don't show work, you're not getting credit. So you could even just say 1 lithium plus 1 oxygen plus 1 hydrogen is 6.941 plus blank equals, and show me your answer. Okay. Sorry I keep turning that so it's more convenient for me. It's less convenient for you. Okay, 39. 39 is a little more difficult because it doesn't give you the formula. So what's the molar mass of nickel 2 chloride? So in order to find the molar mass, you need to know how many nickels and how many chlorines you have, which means you need to write the formula for nickel 2 chloride. So I'm going to do that as I show my work down here. I'm going to turn my body so I don't turn the page on you again. Writing formulas are 4 steps. Nickel is Ni. Chloride is chlorine, which is Cl. So there's step 1. I did my symbols. Step 2 is charges. The charge of nickel is a 2 here. It told me in the name, nickel plus 2. In chlorine, remember chlorine is a halogen. It's right here in family 7A, which means it only needs 1 more electron to be like the noble gases. So it's going to get 1 more negative electron. So when I said nickel 2, but I wrote nickel 1. Let me correct that in red. I apologize. I was looking ahead. Nickel 2 is a plus 2, negative 1. So that's going to be Ni invisible 1, Cl2. So I have nickel, one of them, times how much it weighs in the periodic table, equals. And then chlorines, I have 2 of them, times how much it weighs in the periodic table, which is 35.453, I think. Yeah, 453 equals. Okay. You're going to get those 2 answers and add them together, and that's going to be your final answer. All right. I'm going to let you do 40 on your own. Just make sure you're showing this work here, and you're showing this work here. Okay. Another 40. Look at that. I'm going to let you do the first 40 on your own. I'm going to do the second 40 with you. Okay. Sorry, guys. That's my typo, too. My bad. Zinc, manganese, and oxygen. Finding the molar mass. The hard part of this is counting the atoms. So I want you to try doing this on your own for just a second. How many zincs are there? How many manganeses? And how many oxygens? Okay. Push pause. Figure that out if you haven't yet by looking at the subscripts. All right. Hopefully you figured it out. Zinc. There's no number after it, which means it's an invisible 1. Manganese. There's no number after it, which means it's an invisible 1. Oxygen. There's a 4 after it, but there's a 2 right here. That 2 distributes to everything inside of the parentheses. So that's 2 times the manganese and 2 times the oxygen. So it's 1 times 2 equals 2 manganese. And 4 oxygen, because it's O4, but it's inside the parentheses, so times 2 equals 8 oxygen. And then you're going to go 1 zinc times how much it weighs in the periodic table, plus 2 manganese times how much that weighs on the periodic table, plus 8 oxygen times how much it weighs in the periodic table, which is 15.999. Okay, and you're going to take these 3 answers and add them up for your final answer up here. One of these ones. Good job. If you guys worked all those out, you should be ready for our exam. Way to go.